Okay, we got it. Okay, so Abby made 120 cookies for a bake sale. She sells 3 cookies every minute. We want to be able to talk about this in not only all of its different forms, but also what each of those things represent. Okay, so one way that we can represent a function or a linear equation, right, is with a function rule. So in this situation, we're given a word problem, so let's turn this word problem into a function rule. Asking to write a function rule is the same thing as asking us to write an equation. Okay, so can we turn this into an equation? I'm seeing head nods, yes. So anybody have any idea of where we might want to start to turn this into an equation? So yes, we did so well yesterday at the end of class. Carter, do you think you have an idea?
Wouldn't it be like y equals 3x?
Okay, so y equals something with a 3x. Are we agreeing with something with a 3x? Okay, I'm going to go on board with a 3x. Why 3x? Why is that 3 getting an x? Right, because it's per minute. Anything that's happening per item gets a variable.
Ooh.
Then what?
Plus 120?
Okay, so plus 120. How do we feel about this plus 120? Okay, so now some of us are starting to look at this weird. Anthony, do you have any adjustments you might want to make?
No, I was gonna say it's just equal to how many or whatever.
Well, so this is equal to what? What is this y representing right now?
Total amount of cookies she sells?
Not the total amount of cookies that she sells. Do we know how many cookies she sells? No, right? How many cookies she has sold depends on how many minutes have passed. Okay, so this isn't how many she has sold. This would represent how many she sold, depending on how many minutes. So what does this represent? Not money, because we don't know how much she's actually selling them for. So let's try and think about this in a different representation. Okay, so right now this equation isn't quite right. But that's okay. Sometimes if we can't get it in one form, maybe if we think about it in another form, that will help us figure out what's going on. So let's think about it as a table. Why not, right? That's another representation. Let's try it. So if I put a 0 in here, what is this 0 representing? 0 minutes. So are we okay with x representing our time, our number of minutes? If we don't know what else it should be, x we should usually guess is time. That's a pretty good default to fall to if you're not sure what else to pick. At 0 minutes, what's going on? And how many cookies does she have?
0.
She has 120 because she already baked them. Oh, okay, so there's a good statement. So now if I put 1 here.
117.
117. So what is this 117 representing?
How many cookies she has left?
How many cookies she has left? So what does y represent?
Cookies.
The number of cookies she has at a given amount of time, right? So this is her number of cookies she has left. Okay, is this equation right here matching up with the thought process that we just had of this going down? No, what are we missing? Abby?
Doesn't have to be standard form.
Doesn't have to be standard form. We could write this in standard form, but we're going to hold on to that thought for a little while, okay? What do you think, Marty?
Do you know why it's standard form?
So if I change this to subtracting 120, that would mean I would start with negative 120 cookies. Does that make sense? Well, no, because we can't have negative cookies. Sherry? Why a negative 3x, Sherry? Because we're selling them. Is she gaining cookies? No, she's losing cookies. So we tend to have problems like this where they're a total problem, right? We're doing blank plus blank. Okay, but the total number of cookies that Abby has is decreasing every time she sells them. So you might think about this as the 120 cookies that she had minus the 3 cookies that she's selling each minute. We just don't write it in this form because slope-intercept form is like this, right? This is our correct way of writing an equation. Okay, so now we have an equation. Y equals negative 3x plus 120. What does that y equals negative 3x plus 120 represent? The number of cookies that she has any given minute. Right? Because when I have this word problem, okay, so Abby knows she's selling 3 cookies every minute. But Abby wants to plan for, okay, what's going to be my situation where I need to either start cooking more or I need to start thinking that I'm selling out. Whatever. Right? We're doing a very generic business model. Okay, if Abby only looks at the word problem, she's going to have to start going, okay, at 1 minute, I'll have 117 left. At 2 minutes, I'll have, okay, 117 minus 3 more, 17, 16, I have 114 left. Okay, another 3 minus, okay, 111. How is that going to work as a business model? That's pretty annoying, right? Abby, are you going to want to have to do that to calculate how many cookies you have left? No. But if we have this equation, and Abby wants to know how many cookies she has left after 20 minutes, what is she going to do? Okay, so now I have this equation that says y equals negative 3x plus 120, and Abby wants to know how many cookies she'll have after 20 minutes. What should Abby do?
She put 20 in for x.
Plug in 120. Because after 20 minutes, what variable represents minutes? X. So we would plug this in to calculate how many cookies she had left. Well, that seems way more reasonable. Okay, y equals negative 3 times 20 plus 120. So what's negative 3 times 20?
60.
Negative 60. So negative 60 plus 120 is 60. So after 20 minutes, how many cookies does Abby have left?
60.
60. That's way easier than her just thinking through the story problem and subtracting 3 a bunch of times. Right? Okay, so we can use this like we use function notation or a function rule, and we can plug in values for anything there. How do we feel about that one? So far, so good? What if Abby now says, I wonder how long it will be until I know when I have 30 cookies left, I'm close to selling out, and I need to start thinking about selling out. How long will it be until I have 30 cookies left?
10 minutes.
How do you know that?
Because 20 minutes is 60 cookies, and then half of 20 is 10, and half of 60 is 30.
Is that how many she'll have left, or is that how many she will have sold?
Actually, that should be.
What variable represents up here the number of cookies she has left? Y. So if she wants to know when she has 30 cookies left, is that an X variable or is that a Y variable? A Y. So she wants to know if Y equals 30, what will X be? So what could she do to figure out X? What are some thoughts we have? What did we do when we knew X was 20? We plugged it in for X. So what do we think we should do when we know Y is 30? Plug it in for Y. So if I say 30 equals a negative 3x plus 120,
Subtract the what?
This is an equation I know how to solve.
And you divide it by negative.
Oops, this is a negative 90. How long will it be until Abby has 30 cookies left?
30 minutes.
30 minutes. Does that make sense?
Yeah.
So far, so good? I'm just letting some people catch up with writing, guys. Okay, so now how about this one? I just keep writing down the equation because I'm flipping the page. You know. What if I wanted to graph this? Could I graph this?
No. 120 is not correct.
Okay, so we would definitely need an adjusted size graph. Okay, so let's talk about what type of graph would be reasonable to plot on. Don't write down what I'm about to write down. Would it be reasonable to plot on a full coordinate plane? I mean, can we plot on a full coordinate plane? Sure. But remember what we said yesterday. So I find 120, I go down 3 over 1, whatever. We'll do that here in a minute. What part of this graph is reasonable? What does this point down over here mean? What does positive, 60, negative, whatever mean? Okay, so after 60 minutes, she has a negative amount of cookies. Is that reasonable?
No.
Can Abby sell so many cookies that she's negative? Because she doesn't take pre-orders. Sorry, Abby doesn't have that business model yet. No pre-orders allowed. So is that part of the graph reasonable?
No.
No. So what would be reasonable to have on our coordinate plane? Is this part reasonable?
No.
Is this part reasonable?
No.
Is this part reasonable?
No.
So the only part that's reasonable is, which quadrant is this?
First.
Quadrant 1. So if we are going to graph this, which on your homework tonight, oh gosh, on your homework tonight you will already have it just quadrant 1. But for right now, we are just going to make a graph in quadrant 1, which seems a whole like when we were relating graphs to events. That's a tongue twister, right? And we were just in that quadrant 1 because time can only be positive. Okay, what label are we going to put down here?
This.
Time. What label are we going to put here? Cookies, right? Our number of cookies. So rules for right now. Your graph doesn't have to be perfect, but it needs to fit on whatever you're given and provided. So like when I give you a graph for your homework tonight, okay, you somehow need to make it fit. Right, so this doesn't really matter. We can count down here, we can count minutes, but what might be reasonable to count by if we know we're going to need more than like 10 minutes?
100.
Are we going to need 100? Should I go like 100 minutes, 200 minutes, 300 minutes? No.
Sorry, I meant the other. 10.
Maybe like 5 or 10 minutes? Okay, I don't really care what you pick. Just don't make your graph so teeny tiny that like it's all within this little space. And don't make it so that like you're having to go way over here before you start. Does that make sense? Just like sort of, so let's count by 5s. So 5 minutes, 10 minutes. What might we want to count by over here? Do I want to go 100, 200, 300, 400?
110.
I think we might still want to just count by like 10s, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Do I need to go any higher than 120? Nope. Now here's why I always try and give you a graph that works pretty well, because here we are going to have to approximate. Okay, and for us to get accurate results when we're doing this, we don't necessarily want to be approximating, but so that we're getting the general idea here. So if I want, oh, I forgot my 0 up here. If I want to graph this, where am I going to start? Carter, right?
The 120.
The 120, right? Because my B is 120. Is this in standard form or is this in slope-intercept form? Slope-intercept form. So I want to start at B, which is 120. Then what am I going to do? What do I do next? Down 3 over 1. Down 3 over 1. And here's where, right, here's the dilemma because I'm going to have to approximate that. Down 3 over 1, I don't know. Down 3 over 1. I'm going to put us maybe somewhere in this ballpark of a line. I'm going to kind of fill this in lightly for a minute, and I'll explain here. Just one second. What does that graph represent? It does have a negative 3x, but what does it mean? What is it telling us?
It's usually how many cookies you're selling per minute.
Right? We should be able to look at this graph and decide how many cookies we have per any moment in time. It's just another way of finding it. This is looking at it algebraically. This is looking at it visually with a graph. How are we doing so far? You're like, holy cow, this really is putting together everything we have talked about for like the last 6 weeks, right? What does the y-intercept represent? What does the y-intercept tell us? What do you think, Carter?
How much total cookies she has?
How many total cookies she has when?
Start.
At the start. Okay, our y-intercept is giving us a starting point. Now, I have to use starting point a little bit loosely because it depends on what you're talking about. Start might not make sense. Okay, but we know a y-intercept always has an x value of what? Oh dear. 0.
Oh.
A y-intercept always has an x value of 0. So this is the ordered pair. 0, 120. When no time has passed. That's why this gives us a starting point, because our x value has to be 0. Okay, so in this situation, it's telling us the starting number of cookies. What's our x-intercept going to tell us? What do you say, Jaden?
Time.
What about time? So you're right, we're going to get a number with time. An x-intercept is always a number, comma, what?
0.
0. So what's going to be 0?
Time.
No, because time is our x value. It's our y value that's going to be 0.
Remember.
Anthony?
120.
That's up over here. This is 0. I think you started to say it, Jaden. Just say it.
Number of cookies.
How many cookies will we have when y is 0? 0. So what does our x-intercept tell us?
How much time it gets to 0?
How much time until we have no cookies left? So this is sort of like our ending point. Right? This is when there are no more cookies. Abby sold out. Abby needs to bake more if she wants to have her business open again. What does our slope represent? What does our slope represent? Slope is always a rate of change if it's getting a label. Does that help at all? Okay, so slope is always a y per an x. So what's our y label up here? Cookies. What's our x? So it's our cookies per time. So this is telling us the number of cookies. Now let me ask you this, is it increasing or decreasing?
Decreasing.
How do we know it's decreasing?
It's negative slope.
Negative slope, how visually do we know that it's decreasing?
It's
Because it's going downhill, right? Which is our relating graphs to events, increasing, constant, decreasing. Holy cow, did you ever think it could all mean one big thing? Okay, this is our number of cookies decreasing per minute. Whew, that's a lot. What should our x-intercept actually be? If we had a perfect graph, we would be able to see perfectly. What is our x-intercept? Colin?
30.
How are you getting 30?
That's the
So are you just visually looking here? My graph isn't perfect. So if my graph was perfect, this would be 30, but my graph's not perfect. What could we do to make sure it was crossing at the right point? I'm gonna go backwards to this. Oh, great, okay. I'm gonna go backwards to this page here and maybe tell you to consider something we did down here. See if you can make a connection. Colin, what do you think?
negative 3x plus 120 equals 30.
Close, but we don't want it to equal 30. What do we want it to equal?
0.
0, because how many cookies do we want her to have left? 0. That would be our x-intercept. So if we said, right, if we said 0 equals negative 3x plus 120, and I solved this, this line should have been more over here, right? My line should have been here. That would be a perfect line. Okay, holy cow, that is a ton of stuff to process all at once, right? That is a lot. We're not joking around. I told you it was going to be a lot today. So here's what I